Right. Welcome everyone. Thanks for joining. This is Wasmer Things, an upside-down guide to WebAssembly. So I don't know if you ever joined one of those sessions where the speaker basically has copy and pasted text from a web page. They use terrible fonts, horrible animation, ugly clip arts, overblown fonts, overstretched graphics, and of course horrible transitions. And then they go something like, let's go download mscript, and it's a compiler for WebAssembly, and my favorite download website is 2cows, and then you can write your hello world in C, and then you compile it, and then, sorry, this is my first day, let me reboot my computer, this is the first time, sorry, and you know, and then you print hello world in your browser, yay! So this is usually fun for the first few minutes, but it's a tutorial that you can read on the web yourself. And besides, I mean, it's cool and everything, but it's not really giving you insights of how the whole thing works. So hopefully today we're gonna do something more in that regard. So my name is Edoardo Vacchi, and I'm the last speaker between you and your lunch break. And I did a bunch of stuff in the last few years. I try to be consistent in doing stuff related to programming languages and compilers, and most of the time I did it. So, but the last company that I just joined this January, it's called Tetrate, and now I'm finally working on a proper language runtime called W0, a WebAssembly runtime. So I know my shit. You can find me on the internet pretty much everywhere using that handle, Vacchi. And but you know, we don't really know about the future of the Bluebird. So if you want, you can find me with 100% more Mastodon. So Vacchi@mastodon.social. Back to Wasmer Things. So a lot of people here probably are backend developer, maybe Java developers, and they would be familiar with Java applets, and they would go like, bytecode in a browser? We had applets, you know, we know what that is. Why do we need to talk about another bytecode format for the web? We added. So hopefully I will be able to convince you that WebAssembly is it's not just reinventing the wheel another time. But in order to convince you about that, we're going to have to do, I'd like to do a history of WebAssembly. And history of WebAssembly really is a history of running arbitrary code in the browser. I'll be occasionally quoting from this paper, bringing the web up to speed with WebAssembly. Don't worry, it's not an academic style talk, but I like to use first-party sources of information. And these folks are not just academics. They're actually people from the industry that got together and wanted to develop WebAssembly for a reason. And we're going to go through that. So, but in order to get there, let's do a step back in the past. If you recall, this is more or less the period I want to talk about. There's a bunch of old browsers, among the others, our most loved one, Internet Explorer 6. I didn't install VMs to do this. I download that from this website. You can get a lot of interesting pictures of older browsers. Anyway, this is the period of time I'm thinking about, early 2000s, late 90s. So we have browsers, we have internet connections, but most of us have dial-up connections, if at all. And well, all of these browsers are capable of running some code. Of course, they do run, they do visualize HTML. CSS is just getting started, and there's JavaScript. But at the time, JavaScript is not a serious programming language. It's mostly used for adding a little bit of interactivity, a little bit of nicer graphics to your web page. So basically button rollovers. So it is not meant to be to do a lot of stuff. It doesn't really do a lot of stuff, honestly. And if you wanted to go further with your browser, you had to install plugins. So there's a few technologies with different names, with different kind of trade-offs, but more or less they're all the same. It's a bit of a binary code. It's a dynamic shared object usually that you can link against your browser, and you can do with it anything. I mean, it's native code, so you can do whatever. But usually they're necessary for adding some multimedia interactivity to your HTML web page, to your hypertext web page. So there's Real Player, there's Windows Media Player, there was QuickTime, of course, and then there was Flash and Shockwave, and of course Java, of course, and I'm mentioning also Silverlight, which came quite a bit later, but there was it as well. So, and of course some other crap that for some reason you had to install inside Internet Explorer 6 to navigate on your intranet for some reason. So why don't we like plugins? We've been using those for a while and we needed them and we had to use them, but they're not perfect. Well, there's security issues. The code runs with the same privileges of your browser. And if that bit of native code that you're installing goes haywire, it could take over, at the very least, your user account, worst case scenario, even your entire machine. There's deployment model issues, and these are the worst because this is native code. So you have to support a matrix that is made of architecture, so your type of CPU. And it's not like there's only x86 everywhere. Even if we're talking about client machines, at the time there was definitely still PowerPC and a number of others, of course, but among the most mainstream. Operating systems, of course, there's Windows, there's different versions of Windows, there's macOS, different version of macOS, of course there's also Linux and other operating systems. And of course there's browsers, there's Internet Explorer, but there's Firefox, there's Mozilla, there's Opera, and the different versions. Remember, we're talking about a period of time where Internet was not available at any time. You had to connect to the internet, so you couldn't be sure that your end users had at any time the latest version of your plugin if they had your plugin. So it was user responsibility to keep it up to date, to download it and install it, and this also goes with security issues, of course. So it was a problem for deployment, but of course it was a problem also for maintenance. I mean, for development. People that wanted to release plugins, they had to keep in mind all of these constraints. And of course, well, that's a user experience problem. It was not necessarily a nice user experience because the plugin always felt like an alien part of your web page. It wasn't well integrated. So for several reasons, including these, plugins after a while were deprecated. And I think we have to thank also this guy. Because, of course, it's not like iPhone where the reason why we no longer have plugins or Flash, but definitely they put another nail on the coffin of that technology because they didn't support any plugin. Now, let's think again about JavaScript. So, well, we don't really want plugins. Plugins are a problem. What else do we have? We still have JavaScript, but JavaScript, it's not considered a serious language. This probably was one of the books that started to let people understand that it was not that bad, and it was actually a proper programming language they could use to do something interesting. But let me fast forward a little bit now. Even though JavaScript was not that bad of a language, not everyone wanted to deal with JavaScript. And so people started to target JavaScript as a compilation target. So instead of writing proper JavaScript, you will write some other language, sometimes a superset of that language or a newer version of that language. Babel.js is a compiler that compiles old, newer versions of JavaScript that may not be, at the time especially, may not have been supported on all browsers, and transpiled, that's the term that we've been using, those into an older version so that you could deploy it and have it widely usable across browsers. But I wanted to mention CoffeeScript, which was probably the one language that made transpiling to JavaScript mainstream. There was Dart, which still exists. At the time was both a transpiler and also a VM embedded in Chrome. And of course, TypeScript and NetScript. I'm leaving TypeScript at the end because that still exists and we are using. And NetScript was basically a dialect of JavaScript with types and annotation that was folded back into TypeScript. So that's pretty much where we are. People, that's interesting. The reason why I mentioned this because it's interesting because it's the first time that we start to accept probably that a language that is dynamic, so it doesn't really requires compilation. At some point we accept that a build process in our release pipeline is okay to have, even for web developers. We're not using transpilers and code generators just for JavaScript, but also for CSS and so on and so forth. And there's a number of other transpilers that I'm not mentioning explicitly today, but I do want to mention at least one, GUIT, GW2, Google Web Toolkit, because probably was one of the first, maybe, I think it may even predate CoffeeScript. It was one of the first languages or compilers or transpilers that targeted JavaScript directly from Java. And even though it's probably less of a cool thing now, it still exists, but it's called Jekyll now, J2CL, and it's an evolution of GUIT that addresses a lot of the shortcomings of the GUIT platform. Now let's go further than that. Let's talk. So now the point is, we're starting to put build pipelines even in web development. So we're accepting that. In the meantime, we would like to run. We would like to explore different ways to run native code that are not plugins, different places, different formats. And so an experiment that was released in Chrome was called Native Client, and then there was Portable Native Client. So Native Client was a way to compile C and C++ into a binary format that was runnable inside the browser, but with more safer constraints, safer guarantees. There was a sandbox, and it was unrestricted. There was the native client version that basically had similar shortcomings when it comes to supporting architecture like we had for plugins, because you still had to release binaries for each platform that you wanted to support, but at the same time, it addressed one of the other issues, which was deployment. You just delivered this binary payload with your web page, just like you delivered images and scripts, and you didn't have to require your user to download it manually. So that was a step, a good step. As for Portable Native Client, it addressed also the other issue, the portability issue. Basically, it compiled code, C and C++ code, into an intermediate representation that would be recompiled into native code on your user machine. So, so you had to only deliver one format, and you did not have to deliver multiple architecture. And just a bit of information, the NACL, the native client version, used GCC, and Portable Native Client used LLVM. ASMJS. So yeah, Portable Native Client and Native Client address the problem of being able to run in a portable way native code and being more directly connected to your machine to have more performance, but it still required you a piece of technology that wasn't present in most browsers. So in the 2013, Mozilla released ASMJS. ASMJS was a dialect, a strict subset of JavaScript that could be interpreted by any JavaScript engine, but specialized just-in-time compilers, runtimes, JavaScript runtimes, will be able to understand that this wasn't just a JavaScript dialect, JavaScript subset, wasn't just pure JavaScript, but was something that could be recompiled on the fly into native code. So at the top, so one of the tricks that were used at the top, you can see that's C code, because you can see there's types, int. at the bottom, there's the equivalent written using ASMJS. As you can see, it's pretty much the same. I mean, it's basically JavaScript. That there's this string hint, use Wasm, that an ASMJS aware compiler or runtime would use as a hint. But as for the rest of the code, that's pretty much basic JavaScript code, except that you can see that there's something weird happening with variables. There's an OR, bitwise OR with 0. What's happening here is that this is completely valid JavaScript, but the bitwise operation with 0 doesn't change the semantic of a numeric variable, only or of a variable, only if it is numeric and only if it is an integer. Otherwise, it doesn't make sense at all to do. So this is basically telling the compiler in a backwards compatible way to the runtime, I is an integer and you should treat it as such. So you can recompile it in native code that uses integers to produce fast code. This was just one of the tricks, but when Mozilla released the Epic Citadel demo, they really showed that this had a lot of potential. You had this special build of Firefox running with their JavaScript engine, SpiderMonkey. They recompile C and C++ using mscripten, the mscripten toolchain, into ASMJS code, so JavaScript code with this special dialect, and demonstrated that this could run at native speeds and could render 3D scenes basically like a native program would do. Now, by looking at this video, you could say, well, that's cool, that's nice, but it's scripted. You know, there's no gameplay. But in fact, if you go further on the website, on the video, you'll see that there's actual gameplay. So you could actually play a 3D video game in your browser without any plugins. That was groundbreaking at the time. So what is WebAssembly? This is from webassembly.org. I'm taking also this as a guideline to understand what WebAssembly is and why we want it. This is the lines that we find in this website, the very first lines that we read. It's a portable compilation target. That's what makes it kind of different from other pieces of technology. And for programming languages, it's a binary instruction format for a stack-based virtual machine, and it's enabling deployment on the web for the client, but also for server applications. So that's what really makes it different. I mean, it's not just about the web as in client, as in browser, but it's very it's a web technology that is also usable outside the browser, and that's what makes it interesting for me, and I hope for you too. So what about the JVM and WebAssembly? What's the difference? Why do we need another VM? JVM, you have source code that's compiled into some bytecode format. You have a stack-based VM. You can run it on the client, you can run it on the server, and the bytecode is interpreted by the JVM, but it's usually just-in-time compiled to produce native performance code. So what's the difference with WebAssembly? And let's talk about CLR as well. So .NET is pretty much the same. So yeah, why didn't we choose to use .NET or Java? His history repeating. There's this quote from Solomon Hykes, the creator of Docker. If Wasm and WASI existed in 2008, we wouldn't have needed to create Docker. That's how important it is. WebAssembly on the server is the future of computing. A standardized system interface was the missing link. Let's hope WASI is up to the task. So what the hell are you talking about, Solomon? Docker and WebAssembly? Why? WebAssembly is Linux containers, right? So what are Linux containers? Linux containers are prevalently a sandboxing technology, and Docker also brings packaging and distribution to it. But as for sandboxing, basically it's a collection of Linux syscalls and capabilities that allow you to run in a sandbox your native executable. So what does this have to do with WebAssembly? We'll see that. Again, this is what the JVM is, right? Now, I want to bring to your attention this project that is now dead because the last release was in 2009. It was called Nested VM, and it was an experiment to provide binary translation for Java bytecode. So they were able to compile C and C++ code into Java bytecode, because why not? I mean, it's just a compiler. You can do it for any language, basically. And the way they did it was pretty clever and interesting. They compiled C and C++ using GCC into MIPS binaries and then translated MIPS binaries into Java bytecode. Kind of interesting. Now, that definitely worked, but it was, it is dead. Probably wasn't interesting at the time. And besides, there's another reason. Java bytecode was never really meant to be a general purpose compilation target. That's unsurprising, and there's also acknowledgments for that. This paper, it's about the first time, it's about the introduction of a new bytecode instruction called Invoke Dynamic. And Invoke Dynamic was introduced to support dynamic languages, especially such as Groovy, JRuby, Jython, and so on, Clojure. But the interesting thing is that this is the first time that the JVM developers, the JVM itself, acknowledges that there are more languages than Java. So, however, the JVM was designed for just one language, Java. So when it is used to express programs in other resource languages, there are often pain points, which retard both development and execution. So the JVM is not really meant to target to be a target for multiple programming languages. So what about LLVM? LLVM, it's a compiler technology that everyone uses if you're using Swift or CLang on macOS or anywhere, actually. It's a compiler, or Objective-C, of course, you may be using on iOS or macOS. So, and the backend for that is LLVM. The code generation part is done through LLVM. Now, as the name suggests, VM, this may be a VM. And the cool thing about LLVM is it's really meant to be targeted by multiple programming languages. That's true because, for instance, Rust has been using LLVM for a while, and there's a number of other programming languages that are actually using it as their compilation target. The way it works, there's this intermediate language called the LLVM IR, and then the LLVM IR targets, it's recompiled into multiple targets. So one of them could be x86, another could be R, MIPS, and RISC-V, and etc., etc. However, if you go to their website, they call it a compiler and toolchain technology, and that's okay. But despite its name, LLVM has little to do with traditional virtual machines. The name LLVM is not an acronym. It is the full name of the project. And this is actually bull, because LLVM, well, it is true. I mean, but at the beginning there was this paper. This paper describes LLVM, one of the very first papers of all LLVM, and LLVM stood for low-level virtual machine. However, to be completely fair, what they do say is that it's not a VM in a traditional sense, and that is true actually. The first versions of LLVM shipped an interpreter, but they no longer do, because it was never performant, so it's not useful. This is how LLVM IR looks. If you squint enough, you can see there's a string at the top that says hello world, and you will recognize printf, and this is just a way to resolve a pointer. So basically what's happening here, we're printing hello world in a C style. So there's argc, there's argv. If you look at it, you can see it. I mean, it's not that hard of a language from a certain standpoint. But of course, you're not meant to write it directly. This is meant to be generated by a compiler. Right, so it was never really meant for fast interpretation or execution. So, and besides, there are other reasons. And this is one of the quotes that I was mentioning from PLDI 17, Bringing the Web Up to Speed with WebAssembly, the paper that I mentioned at the beginning. We investigate reusing another compiler IR, which is a binary format. LLVM bitcode, that's how the IR is called, IR stands for intermediate representation, is the binary format used by Pinnacle, the portable native client. So remember, these are developers that comes from the industry, and they have worked in different pieces of technology. And so they had that experience, but it didn't really work. There are many disadvantages with the LLVM bitcode. It is not entirely stable. Any major version may change the bitcode format. It has undefined behavior like C. It's less compact than a stock machine. It requires every consumer to implement LLVM or ship with LLVM. So imagine in your browser you would ship that project together. And the LLVM backend is notoriously slow because it's really meant just for being a compilation target, because it's really meant to do transformation and optimization, not to be run directly. So, not LLVM. What about JS runtimes? They're already available, and I wanted to show you this picture from Chrome. I mean, this was the first release of Chrome, and I don't know if you recall, but there was this comic that explained why Chrome was cool. And this comic was explaining that it was the first time that a major browser, mainstream browser, shipped with a just-in-time compiler for JavaScript, because SpiderMonkey from Mozilla arrived after that. So yeah, we have already in our browsers JIT technologies. Can we leverage that? And that's the idea for WebAssembly, being a portable compilation target that can leverage technologies that already exist. As compared with other technologies, it has a compa representation. It's efficient in validation and compilation, as a safe, low to no overhead execution. It's interesting because it's an abstraction over modern hardware, as compared with, for instance, the JVM. The JVM bytecode is not an abstraction over hardware. It's just a compact representation of the Java language model, and which makes it well suitable for being platform independent and with use cases beyond just the web. So the cool thing about WebAssembly is, among the other things, it's one of the compilation targets for LLVM. So if your language uses LLVM as a build toolchain, then you can already support WebAssembly, more or less. And there's a number of languages that are already supporting it, and the list is growing. There are a number of runtimes. I'm going to go through a few of them later if we have enough time. But before that, I wanted to show you the difference between the bytecode format. I wanted to show you the bytecode format for WebAssembly and compare it with also Java bytecode. So the interesting thing about the stack machine for WebAssembly is it's not just a stack machine. It's not exactly equal to the JVM. It's a structured stack machine. So of course, it uses a stack of values, but the control flow is expressed through structured constructs. There's no unstructured jumps. Usually in a VM or in an architecture, in a CPU architecture, you have branches that jump at arbitrary places in the code. There's no such thing in WebAssembly. There's ifs, there's elses, and there's blocks, and there are loops. We're going to see those. Why do we want that? Still a quote from that paper. JVM, CIL, which is .NET, Android, Dalvik, allow bytecode to create irreducible loops and unbalanced locking structures, features which usually cause optimizing JIT to give up, which is something we don't want. In contrast, the structured control flow WebAssembly makes validation and compilation fast and simple. So it loads fast, it runs fast, and paves the way for other features. Yeah, this is a duplicate. Okay, let's get, oh yeah, it's a duplicate because now we're going to see these examples. Okay. An example of JVM bytecode. Don't be scared if you never saw that. At the top there's an expression. So we are first summing the value of x to 2 and then doing it times 3. So let's suppose x value is 3. So what's happening in the function is that first we are loading the first variable. I load 1. We load the variable x, of which the value we said is 3, and then we put 3 on the stack. And then we put the constant 2 on the stack. So on the stack there is now 3 and 2. And now we evaluate add. So we pop two, it's a binary instruction, so we pop 2 values from the stack. There's 3 and 2 on the stack. Add the 3 and 2 gives 5. Great, you're paying attention. So we push 5 on the stack. Now we push on the stack the constant 3. Now on the stack there's 5 and 3. Mul is a binary instruction that pops two values. So there's 3 and 5. 3 times 5 gives, great, 15. What about WebAssembly bytecode? So if you take a look at the left, you'll see that it's pretty much the same. Get value x, constant 2, add, constant 3, multiply. Same thing. The interesting thing happens on the right. There's a different representation. This is called the Wasm text format, or WAT, or for short. On the right-hand side, you'll see that there's a different representation that reminiscent of Scheme and Lisp. That's not necessarily an accident. If you know the history of JavaScript, you will know that it was born as, initially, it should have been a Scheme variant, and then it wasn't because Java. And people wanted to have a Java-like syntax. And yeah, but even if you don't know Scheme, basically this is evaluated using the rules for parenthesized expression. So you start from the innermost expression and then you go outside. So you start from the innermost. So you get x, which is 3, and that expression returns 3. Then you define the constant 2, and that expression returns 2. And then you go to the outer expression, which is add, which adds 3 and 2, which gives 5. Come on, guys. I know, it's almost time to have lunch, just 15 minutes or more. Okay. And 15, right. So the result of the add expression is 15. The result of the constant expression is 3. So it's 15 and 3 multiplied, sorry, it's 5 and 3 multiplied, so it's 15, right? Okay, if you noticed, we did exactly the same order of evaluation of the left-hand side. So the right-hand side is completely equivalent to the left-hand side, it's just that the right-hand side it's a bit more readable. That's called the nested representation for Wasm bytecode, and they're completely equivalent. The left-hand side, it's the one that is basically serialized to bytecode. An example of structured and unstructured control flow. Let's say you have this function print. If x is true, it prints 1. Otherwise, it prints 0. Not particularly interesting. But what I wanted to show you is that the control flow has unstructured jumps. If equal, jump to 14. Otherwise, go to 21. So go to the line 21. So these are unstructured jumps. You can jump to anywhere in the body of that program. This is not possible in WebAssembly, where you have proper if-then-else constructs. This is the nested representation. There is also not a linearized version without nesting, where, but still, you have blocks of instruction. You cannot jump to arbitrary positions in your code. And that's for safety reasons, explanation. All right. But now let's get to the part that it's the most interesting to me, and the fact that we can target the browser, of course, and that's interesting, definitely. We can now have a compilation target for any language, not just JavaScript. We can write any language running our browser. That's pretty cool. But server application, because this is not a web as in browser technology. It's a VM. You can run it outside. So that's where Solomon was going for. And he's mentioning this WASI. What is WASI? So the point is Docker is all about sandboxing. I mean, of course, there's packaging and distribution, but containers, they're all about being able to run executables in a safe environment. So what is WASI? Well, you may have noticed that Docker has released a beta version of support for WebAssembly, and that also makes it even more interesting. So what is WASI? Well, WASI is the WebAssembly system interface. So the WebAssembly specification only describes a VM, so the instructions. But what about libraries? What about doing stuff? I don't want just to do, sums and multiplications and cool vectorized operation. That's cool, of course. It's fast. But I don't want to just do math. I want to do stuff. I want to interact with an operating system to do things. And the one thing that I can do, of course, is through a browser. And through a browser, I have JavaScript glue code that loads the WebAssembly binary and then interacts with it. Either it could link it to the browser, which then goes to the operating system and does stuff, or I could run from JavaScript WebAssembly binaries, stuff like that. But what if we don't want a browser? What if we want to run something outside the browser? Well, we have Node.js. So Node.js is able to run WebAssembly binaries. How does that work? Well, you still have to wrap it inside JavaScript. So can we do without JavaScript? Can we just go straight from WebAssembly with any language that I want, go straight to the operating system? And that's what Wasm is. Basically, it's not a standard library. It's not like the JDK. It's not like the Python standard library. It's just a collection of syscalls, like POSIX syscalls. So basic building blocks and operations, then you can build a standard library around. But the difference between regular POSIX and the reason why it's not just POSIX is that it puts an accent on safety. So you do not have unrestricted access, for instance, to the file system. You give it a position, and then your executable will only see that directory, for instance, which is kind of like how applications run in our smartphones. So you have to give and grant that capability. So it's a capabilities-based system. And the same goes for file system, for networking, which is basically, if you think about it, what Docker does. So you do not give unrestricted access to your application, to your operating system, but only to view of your operating system. And that's what Wasm does, but without running native code, but code that runs in a WebAssembly runtime. Well, this is a brief comparison between JVM and WebAssembly. Basically, WebAssembly, it's more biased towards hardware, and there's no standard library so far, so every language brings their own language model and library. It's being developed as part of a working group, as opposed with JVM, which is an open development, an open source project, but of course is mainly steered by Oracle, even though it's an open source development process. It is still that. There's a language bias, of course, and dominates the backend, and it also has garbage collection and an object model and a standard library, which WebAssembly does not have for now. Now, a few words about runtimes. I have not a lot of time. I will go pretty fast. I also have a few words about Java runtimes. I don't know if we have enough time for that. Spoiler alert, there's not many, and they don't really work outside the browser. So, but there's a few. Okay. Anyway, there's a bunch of... So what is the runtime, WebAssembly runtime that Docker is adopting? That's called Wasm Edge. And I wanted to mention Wasmer because it gives the title to the talk. It's not just a pun. And speaking of Wasmer, they're also trying to build an ecosystem around WebAssembly, and that's why they have Wasm, for instance, the WebAssembly Package Manager. So remember Docker, deployment, and packaging. Here we go. Wasmertime is the most widely deployed and used WebAssembly runtime. It's written in Rust. It's being pushed by one of the biggest communities around bytecode, about WebAssembly, which is called the Bytecode Alliance. Envoy, however, so I wanted to, these are runtimes. I also wanted to mention projects that embed a WebAssembly runtime for doing stuff, for doing extensions such as plugins. This is Envoy. Envoy is a proxy, and it uses WebAssembly to do HTTP middleware. This is RedPanda, which is a Kafka implementation that uses native code and uses WebAssembly for doing data transformation close to the data. There's also people that do weird stuff. This is the Zig programming language. It's a cool programming language, and they use WebAssembly to bootstrap the compiler, because why not? This is Lunatic. It's a WebAssembly runtime. It is based on Wasmertime, but it puts their own spin on it. It allows you to write actors, as in Erlang actors, using any language. Pretty cool. Crosslet allows you to run WebAssembly as a container, basically as a pod inside Kubernetes. Same goes for crun in a different way. And speaking of spin, this is Fermion Labs. It's an interesting startup that's pushing a lot, putting a lot of effort into promoting WebAssembly. They develop a tool called Spin for doing web application. We're going to see that in just a sec. Wagi, an interesting piece of idea. Okay, we don't have a standard library. We have a very limited set of capabilities. How can we write proper web applications? Well, let's use the same process as CGI. We use standard input and standard output and environment variables, and that's a web application, except you could do denial of service with native executables. In WebAssembly, you can run it in a safer way, so preventing denial of service. And this is where we talk about WAS0. I only have 5 minutes. So this is the project I'm working on. It's a Golang project, so it's meant to be for Go developers, but you could also run it on your command line, and we're going to see that. There's a bunch of cool use cases. People are using it to run Rust code inside Go, to run C++ code inside Go, to create dynamic linking capabilities inside Go, which is not capable of doing that otherwise, unless you use CGO. There's the startup. They're doing a WebAssembly-based functions. Dapper using WAS0 for Wasm extensibility, and that's the demo. Let's go back to Wagi. So the idea is that with Wagi, you can create a very simple hello world kind of program. What this hello world program does is it looks for an argument on the command line, and it prints hello world unless there is an argument. So let's see an example. Was0 run examples hello.wasm, and if I don't give any arguments, it just says hello world. But if I say name equals voxid, it will say hello voxid. But the cool thing is that I can spin up. So if I have this configuration file, I can mount this pretty simple executable that runs on the command line and make it a web application. So the way this works is that I just write spin up, and then I go to this browser, and there's your hello world. But if I say name voxid, it will say hello voxid, applause. Thank you. The cool thing is that, however, it is pretty easy to write the same exact thing with Go using WAS0. This is just a bunch of lines that I used to do the same thing using WAS0. So if I run WAS0, run, sorry, that's embedded. So it's Go run main Go run main Go example hello Wasm, and then I go to localhost, and it will do the exact same thing. Okay. Applause. All right. So the other thing that I wanted to show you, it's very quickly another quick demo. This was Wago. You can find it online. It's a very simple example. I wrote it in like an afternoon or less, like 2 hours. No, probably less than that, like 1 hour. And but you can play with it if you want to play with Go. I mean, if you're a Go developer, definitely you want to try it. I wanted to show you a couple of other demos. You can run cow save written in WebAssembly. So you can say that WAS0 is awesome, and also that Vox is cool. There you go. And finally, I've recompiled a version of the classic Zork text interactive fiction game, and I can run it through WAS0. There you go. There is a small mailbox. Open the mailbox, and then you can read the leaflet, and there you go. And now I'm quitting. Or you can also save the state and reload it. Like I don't remember. Do you wish to leave the game? Yes. And that's it for today. If you have questions about Java, we didn't have enough time for that. I have a few more extra slides, but yeah. Any questions? Except when is lunch, which is in 10 minutes or so. Yes.
You seem very enthusiastic on the future.
Yes.
On the back end and stuff. what do you think personally? Like, when would we have some kind of universal Docker-like thing that everybody uses Wasm?
Well, it's so the question was since I look so excited about WebAssembly, it's not necessarily so. It's just for showmanship, but just kidding. So why and when do we actually will we actually able to use this in the future for replacing Docker? So people are working on supporting WebAssembly, and it's not extremely easy because it has a bunch of limitations. It's definitely not something that we can adopt right now for general purpose applications, but the ecosystem is really evolving. There's a lot of languages that can already target WebAssembly, although they're kind of lower level languages. I mean, they don't have, most of them do not really have support for garbage collection, and so that hinders a little bit the ease of use, so I would say. So, but things are evolving. There's nothing inherent in the WebAssembly specification that does not allow you to implement a garbage collector inside your WebAssembly binary, and some languages are doing that. For instance, Go, through TinyGo, does that. Java is not supported yet. I mean, there are a few projects that are trying to support Java on WebAssembly. There are many that are pretty cool, such as TVM. There's also a fork for TVM that supports WASI so that you can run it outside the browser. And it's promising, but they're not quite there. I think that in the next few years, definitely not necessarily next year, but next few years, we're going to see a lot more popping up here and there. Oh, I should also mention Kotlin. Kotlin native is starting to support WebAssembly. And they're definitely trying to support it through also the garbage collection specification, which is a draft specification that is not widely supported yet in WebAssembly. Other questions?
One more question.
I have some questions.
Yes.
Are there any security holes that we have to watch out in Wasm, just like in advance?
Security host? What do you mean?
Yeah, I mean anything that has something to do with security or.
Oh, that's a great question. So the question was, are there any services or projects that are related to security that are leveraging WebAssembly? Is that your questions?
Oh, no, I mean,
no.
Using the technology Wasm, is there anything that we have to watch out in terms of security?
Oh, okay. To watch out. Okay. Well, I mean, it's an evolving specification, and while they're striving to do this WASI syscalls system that it's safe, I guess people should strive to battle test these APIs, and of course, the sandbox is as strong as the implementation is. So the cool thing about WebAssembly is that there is not just one implementation; there are many implementations, so you can pick the one that you want to use. And definitely, we're going to see a lot of testing and evaluation of these runtimes, even from that perspective. I also want to answer the question that I misunderstood, which is if there are runtimes that focus on WebAssembly from a standpoint of a safe evaluation. There's the project NARX, ENARX, which is a trusted computing platform, I think, that uses WebAssembly as one of the language for running. It's an interesting project for the user. So WebAssembly is being used and experimented with for a number of use cases. So it is interesting, and I think people like us that are doing backend, besides people that are also doing front end, should take a look because it's should keep an eye on it.
Thank you.
Thank you.